Yeah. Next we are going to discuss some applications of stack. That is second part of this demonstration. Here we are going to discuss some basic applications of a stack. There are the two categories. One is real-time applications and another one is computer-oriented applications. Go to the next slide. In the next slide, we have mentioned that is applications of a stack. That is, here we are going to discuss some different applications in which areas we are using the stack. Then the fundamental application we have selected here is that is Towers of Hanai. I lessened the Towers of Hanai. In this Towers of Hanai, here we are concentrating on, in our hand we have some several disks. That is, we need to transfer, we have some towers or we have some poles. Every pole must be contains some several disks. How we can arrange these disks on these poles is, first we need to arrange a larger disk on the pole. On that larger disk we can arrange smaller disk than that larger disk. Then we can arrange again smaller disk than the second one. Then fourth one is very smaller than the third one. So while moving from bottom to top, always the radius of the disk must be reduced. That means the largest disk is placed in the bottom level as a bottom disk, and the smallest disk is placed at the top of the pole. So this is the scenario, and always here we need to move a disk from one pole to another pole. So in this application we are using the stack. Now we will see how this in this application stack will be implemented. Then we'll go for next slide. That is, here we have some description or we have specified some information about the Tower of Hanai. So that is, here we have taken three poles, pole 1, pole 2, pole 3. And you can observe how the totally here we have 5 disks, and you can observe that how these 5 disks will be arranged on this pole 1. So while moving from bottom to top, the size of that disk must be reduced. The first disk must be larger than second disk, second must be larger than third one, and so on. And the next goal, what is the goal here is, we need to move the disk from one tower to one pole to another pole. While how we can move that disk from one pole to another pole, that is the main goal. And here we need to follow some conditions. What are the some conditions is, always we need to move only one disk at a time. We can move only one disk at a time. While moving a disk at a time, only one, here we need to follow some condition. What is that condition is, always we can move one disk and we can place a smaller disk on the topper disk. And always we must place topper disk on always we must topper disk must be a smaller when compared to the bigger disk, and bigger disk must be smaller disk must be placed on the top of the bigger disk. That is the condition. And here goal already we have mentioned, we need to move disk from one place to another place. Then go for next slide. Here already I have given, we have taken 3 animals or 3 elements. Better to consider these are the elements. Elephant is element 1, dog is element 2, and another animal is another thing will be considered as the third element. Now our goal is, we need to shift all these 3 elements from one pole to another pole. But we have the condition, at a time we can shift only one animal or one element, and always while pushing, while performing, while inserting an element into the disk, we must insert only smaller element onto the bigger element, or smaller disk onto the bigger disk. Then go for next slide. Here first we have shifted top of, and always we must move only the top of the disk. The top of the pole is only the small element that must be shifted to, that must be transferred from disk 3 or pole 3 to pole 1. Then we need to go for next slide. Here we have shifted second smallest element from pole 3 to pole 2. Then we have shift the fundamental application we have selected here is, that is Towers of Hanai. I lessened the Towers of Hanai. In this Towers of Hanai, here we are concentrating on, in our hand we have some several disks. That is, we need to transfer, we have some towers or we have some poles. Go for next slide. Here we have shifted an element from third pole to first pole. Then go for next one. We have to shift the top of that second pole, that is smallest element, must be shifted into the third pole. Then we need to shift, then we need to, for next slide, we need to shift dog element from the second pole to larger element, that is an elephant. Then next go for last slide. In this slide we need to shift that smallest element onto the top of a bigger of its element, that is dog element. So now here you can see the scenario. Finally we have shifted all the elements, all the disk, all the elements must be transferred from pole 3 to pole 1 without any disturbances. At a time we have followed only one disk we have shifted, and always placing must be done smaller element on the bigger element. This is the real-time example regarding to stack where we have implemented the stack. Then you see in this algorithm, here we have taken one function, that is the Hanai function, that is a user-defined function, and in this function we have taken number of disk, and we have taken another from pole, we have taken another variables from pole to pole auxiliary. From pole means a pole from which we need to transfer, to pole means a pole to which we need to transfer, auxiliary means via or through which pole we need to transfer. Then we have taken one condition, that is disk is greater than or equal to 1, and we have called a recursive function Hanai with a number 1, that is disk minus 1, and we need to transfer a element or disk from pole to from pole to pole via auxiliary. Then pop function has given a result, that is D, and push function D represent a disk which we need to push or which we need to perform. Then again we need to call a recursive function with one disk minus 1, and here we have taken, we need to exchange from auxiliary to from pole, we need to shift via to pole. So this is the scenario. So yeah, at the time always disk minus 1 is placed stored in disk minus 1, and auxiliary can be stored in pole from a pole, and 2 pole is stored in auxiliary, and from pole is stored in 2 pole. Repeat this recursive function until disk is greater than or equal to 1. If disk is greater than or equal to 1, and all our disk must be arranged in proper way by satisfying our conditions. This is the real-time example, or application where the stack can be used. Then we can go for next slide. That is another applications regarding to computer oriented or computer applications. In there the first application is convert infix to postfix conversion and evaluation of expression. Infix means normally the user follows infix notation. The operator must be written in between the operands. The operator must be right before the operands is called as prefix. The operator must be written in between the operands is called as infix. The operator must be right after the operands is called as postfix notation. To convert from infix notation to postfix notation, we need to use the concept of a stack. Then we need to go for another application is evaluation of expression. See, in this evaluation of expression, here we need to concentrate on how the expressions will be evaluated based upon the priority of operators. So coming to one example,